All right, number 21 for the practice exam, for the fourth practice exam. It's the last write-up question. It says at alpha level 0.05, is there a significant difference in the proportion of strokes in the two aspirin groups? If you're not reading the question, some of you might foolishly, because you recognize the table, you might foolishly want to plug it into a matrix and calculate the chi-squared statistic. But see how we made it pretty clear that it's a proportion question. And not just a proportion question, it's a two proportion question because you have two proportions. So if we look at this table, what it actually gives us is a count of successes and the number of strokes over the total number of patients that they test or observe. So 206 over 1649 is your first proportion, that's p hat 1. And then your second proportion is 157 over 1650. So right here, we wrote that out. Okay, so now that you know it's a proportion question, we can set it up. Remember, when you set it up and you talk about your null hypothesis, and this has been, we teach it all the time, and this is probably repeated 100 times in my class at least, maybe not that much, but for your null hypothesis, you want to say that there's no difference between your two proportions. And then the alternative is pretty clear right here. It says, is there a significant difference? So they want to calculate just not equal to any difference at all. The alpha level is 0.05, so that's given to us. Again, the best way to solve most of your questions is through the calculator. But if you prefer doing it by hand, then by all means do it. This is the formula to calculate z for a two proportion z test. But let me show you how to do it in the calculator just to save you time. Go to stat test, and right here it's two proportion z test. There's no such thing as a two proportion t test. That's not ever taught to you. So don't try to look for that because it's only z test for proportions. So press enter. And the rule of thumb that I always teach my students is that you want to put your higher proportion first. So for x sub 1 and n sub 1, 206 over 1649 is the higher proportion. And we do that because we subtract. So if you follow my mouse, we subtract your two proportions, and you want to avoid negative z test statistics. Unless, of course, if you have sequential proportions. What I mean by sequential is that you're given a proportion for 1990 and a proportion for 1991. So you have to follow the sequence, whether even if the 1991 is a smaller, bigger proportion. So you have to follow sequence. But because this particular question doesn't have sequence, we just will put the higher proportion first. So I hope that's clear. I don't think that's too confusing of a concept. So I put my two proportions in, and my alternative is not equal to, and then I'll calculate. All right, calculating 2.73 right here is my z value, my z statistic. P-value is 0.0063, so they round that off. And then to make a decision, we compare our p-value to the alpha level. So 0.0063 is less than 0.05, so we reject the null. And if you if you don't make a good conclusion, then you don't get full credit. So the conclusion part is pretty important. It's a pretty important part of the question, and it's got to be, your conclusion has to be in the context of the question. So for this conclusion, there is a significant difference in the proportion of strokes in the two groups. That's perfect. That's fine. If you have something like that, you're set. Again, you can do all of this by hand if you prefer. Just don't mess up, and show all your work if you do it by hand. But for the most part, all we need to see is z is equal to 2.73 and p is equal to 0.0063 for you to get full credit.